Let's continue solving our equations. Remember that we have VE bar equal to del squared V0 bar d xi squared equal to d squared d xi squared of V0 bar, which is a xi squared over 2 plus 0 plus b over rho, which is equal to a plus b del squared d xi squared 1 over rho plus c d squared rho d xi squared. And from here we can also define VE prime in this fashion. We have c d squared rho d xi squared, which is exactly coincident with this term here, plus b d squared d xi squared 1 over rho, which is coincident with this term, and we are going to change only this term here. So we put a over 2 xi squared minus eta squared over 2 minus zeta squared over 2. Why can I do that? Well, because if we consider the Laplacian of this term here, it's still equal to 0, just like the Laplacian of this was. But this will allow us to find the solutions. So, of course, it is not so intuitive in this case, but it's just mathematics, and we can do this. Okay, so the Laplacian of V bar E prime is equal to the Laplacian of V E bar is equal to PE over K. Then remember also that we have U prime non-zero, V prime equal to 0, and W prime equal to 0. And U prime was equal to minus derivative with respect to xi of 2c over rho. We found it last time. And U, if we also want to find U, in this condition we have dv bar E prime dxi plus U prime. Now the calculation yields d over dxi of c d squared rho dxi squared plus b d squared dxi squared 1 over rho plus a over 2 xi squared minus eta squared over 2 minus zeta squared over 2. And then we also have plus U prime, which is simply equal to this. So we have minus 2c d over d xi 1 over rho. And this is equal to a xi plus 2c xi over rho cubed. This comes from the derivative of this, whereas a times xi comes from the derivative with respect to xi of this term. And then we have plus d over d xi of c d squared rho dxi squared plus b d squared dxi squared 1 over rho. Now we can choose also to rename the constants. In particular, I will choose the name A. So I will choose this label. A, it will be equal to capital A, whereas C is equal to capital A times another constant C prime, and B is equal to capital A times B prime, where A here is exactly the constant that we mentioned when we spoke about the dilatational constants, capital A, capital B, and capital C. So U can be rewritten as A times xi plus 2c prime xi over rho cubed plus derivative with respect to xi of c prime d square rho d xi squared plus b prime d squared d xi squared 1 over rho. And similarly, by carrying out the same line of thought with different conditions for w prime and v prime, because remember that we found this expression, which is not the final expression, since we still have to use superposition. We found this expression by considering u prime not equal to 0, w prime equal to 0, and so the second component is v prime equal to 0, w prime, the third component, equal to 0. We also have to use superposition because we also have to consider the case where u prime is 0, v prime is non-zero, and w prime is 0. And in this case, we find for the second component, v, something similar. We will have a different constant, capital B, and instead of xi, we will have era plus 2c prime times era over, what do we have here? We have rho cubed, the same thing, but here we have the derivative with respect to era of c prime d square rho d era prime plus b prime d squared d era prime 1 over rho. So by using superposition, this is what we have. Let me close the brackets here. I also have to close the bracket up here for u. And similarly, if we consider the case u prime equal to 0, v prime equal to 0, w prime not equal to 0, we get for w the following equation: c times 0 plus 2c prime 0 over rho cubed plus d over d0 of c prime d square rho over d0 squared plus b prime d squared d0 squared 1 over rho, like this. And now we can rewrite u, v, and w in the following form. After we use superposition, what we get is the following. So we get u equal to a times xi plus 2 c prime xi over rho cubed. So this part is exactly the same. It stays the same. Let me highlight it above. It's here. This part stays the same. Then we have the content of these curly brackets, this one, and this one, which are going to be summed. Why is that? Well, because if you remember, we started our derivation from here, where we set these derivatives equal to 0 when we consider this condition, u prime not 0 and v prime is equal to 0 and w prime is equal to 0. So what we have to do is we have to sum the part inside this curly bracket with this one and this one for each of these terms. So let me write it down here. We'll write the expression for u like this: derivative of a function f that I will define in a moment with respect to xi. Then we have the velocity v equal to b times era plus 2c prime era over rho cubed plus the derivative of the same function f with respect to eta, and then we are left with w. So w is equal to c times 0 plus 2c prime 0 over rho cubed. So let me rewrite it more accurately. 0 over rho cubed plus derivative of f with respect to 0. So finally, we only have to write the function f. The function f is equal to a curly bracket c prime d square rho dxi squared plus b prime d squared dxi squared of 1 over rho. And this is the first part of the function f. So I have simply rewritten, where is it, this term here. And I have to sum to that term this one and also this one. So let's do it below. I have plus b c prime d square rho d era squared plus b prime d squared over d era squared of 1 over rho plus c prime d square rho d 0 squared plus b prime d squared d 0 squared 1 over rho, like this. And so this is the functional form of f. You can see that we have to calculate a bunch of derivatives because we have the derivatives that appear inside the function f, and also we have derivatives of f. So we have several derivatives to calculate in order to find the final expression for the velocities, the components of the velocities. So this is what we are going to do next time. And then after we calculate the velocities, we can also calculate the pressure. And from the pressure, we can also find an expression for work. But first things first, we will start doing that next time.